Hi guys, welcome to our webinar, and we have with us Joshua and Vinay. So the topic of the webinar is why should Gen AI adopters switch to GraphRag-based AI agents? So who is this webinar for? So the webinar is for product managers, engineering managers, who wants to streamline the Gen AI workflows, people who are serving their customers with generative AI and make sure that you want to give a very reliable AI service to your customers, and of course generative AI app developers. So now for the introduction, I would ask Joshua to come on stage and introduce himself.
Hey guys, sorry there's some issues at my end. Yeah, I'm Joshua. I'm the CTO of CogniSwitch, and I spent a decade in AI, ML, and platform building for knowledge bases, etc. Yeah, that's it from my end. I'll hand it over to Febin. Thanks.
Cool. So we have with us Vineet, who is the CTO of TARS. Vineet, please introduce yourself.
Sure. Thanks, Fabin. Hey, everyone. My name is Vineet. I'm the founder of TARS. So TARS, I've been working on the TARS for the last almost 8-9 years. And TARS is basically a conversational AI platform that allows people to automate conversations across the board, primarily focusing on customer conversations. And now we are also focusing on internal conversations within the team. And in today's webinar, we'll talk about different ways that we can improve conversation automation, primarily using Gen AI capabilities, LLMs, and what are the pitfalls, what are the problems, what are the learnings that we had over the past 1 year, 1.5 year to implement this thing. So yeah, I think looking forward to have this thing.
Cool. So to start off with, Vineet and Joshua, you can talk about the present state of AI agents and what are the kind of challenges which you guys are facing right now and how you are tackling it, right? And what is the kind of solution which you can provide to our viewers as such. So over to you guys. Yeah.
Cool. Thanks, Joshua. Do you want to talk about the first two stories, and then I can talk about some of the internal customer stories?
Hey, I can't hear anyone, but I'm just gonna go by what the screen is saying. You're talking about the Air Canada issue and how you had to refund. I think that's the issue. So what happened in that case would be a case where there was a concept that was similar, but not exactly the concept that was being spoken about, and then things went really wrong in that situation. I'm completely, I can't hear anybody right now. So thanks.
Okay, Fabin, maybe you can see what's the issue. Fabin, also, do you want to stop the music?
Oh, actually, there is no music. Let me just check it quickly once.
Sure. Okay, it's not disturbing, but I can. Yeah, I think it's gone now. Cool. So I'll just talk about the some of the stories that is mentioned. So we are basically we want to talk about what is the current state of AI agents and what has been our learning over the last 1 year, 1.5 year when trying to implement these customer chatbots or customer use cases. So I'll just start with some of the very popular story that you must have heard, especially something like Air Canada story, where the Air Canada being an airline, they have basically made a chatbot which is built on top of AI and LLM technology. And what happened was, it was there on the website. A customer asked for a particular refund policy, and the chatbot pretty much like made things up by itself, which is not even there in their refund policy. So as a result of that, the customer got a refund, or basically they thought they got a refund. They can claim a refund even though there was no policy around it, right? And as a result of that, it turned into a huge thing, a huge lawsuit, and I think that is something the company had to bear in terms of problems, in terms of trouble, because the chatbot or the AI which they thought it's ready for production was not really ready, right? So that's a very popular, probably you've heard that story. Another one is about a lawyer. Basically, the person try to use, no, basically they use chat gpt to save their time, and they try to make their case, for some filing. And the chat gpt, or AI rather, they basically referred to some law or something which is not existent. So it basically it referred to something which is not even there. So it's purely like that is a pretty much definition of hallucination. And the person, the lawyer himself, he did not cross checked it, and they presented it. And that got into a lot of trouble. I think they got fired as well. So these are the two very common, I mean, it's very known stories about the problematic nature of when you're trying to go live or go to production with AI agents. I'll just stop here. Fabian, are you able to hear me properly? Like, is it okay?
E- Everything is good, Vinay.
Yeah. Cool, cool, cool. Joshua, are you able to hear me now?
Yeah, Vinit, I can hear you now.
No?
Yeah.
Okay. Great, great, cool. Cool. So I just move on. So in this part of the webinar, we'll primarily talk about what are the challenges, what are the problems that we have faced as we try to implement it. So, for example, I have two customer stories where we have worked with these two customers and face this problem ourselves when trying to go live, when trying to go to production with these two companies. The first one is an e-commerce company. Basically, it's a small. They have a smaller set of products that they had, and it's a e-commerce in the baby product kind of category. And one of the challenges that they faced was related to the accuracy. So they made their use case was very simple. They had these around 20 products, 20 e-commerce products, which is very highly specialized, specific to their product, that their company. They are the one who created this product, and they had a bunch of help docs. It's basically a technical product. So they had a bunch of help docs which explained all the features of that product, right? So they wanted to make a chatbot where any questions, any technical questions, any refund related questions, any delivery related questions, all those things can be answered through this chatbot. So that was their idea, that was their vision, to make a chatbot which can answer these questions, so that they can save time, and they don't have to answer these questions manually through a person, right? So they made this chatbot. So they worked with us. We built this chatbot, and so one of the challenges initially on when we faced is that the chatbot got confused a lot when asking questions about their products, primarily because the product name that they had were very similar in nature, and all the documents, all the help docs that they shared with us, that we consumed as part of the knowledge ingestion, and basically vector rack, which I'll talk about, and we ingested it as a vector into our vector database. That was like it had like it has information about all the products basically in one place. So because of that, and because the product names were very similar, the chatbot got very confused, asking, when you asking questions about one product, it gave the answer referring to some other product which was not even that, right? Which is not correct. So that is a main problem that we faced with them. And finally, we solved this problem by segmenting the knowledge base from their help docs into different places, and then taking different routes. So that's a solution that we built, and it kind of worked, but we did face a lot of challenges, right? Another quick story I can talk about, very similar, but in the higher education space. Basically, this other customer that we had, they're basically giving these, like, degree programs and diplomas for students, and they had this chatbot where the students, or the prospective students for the institute, they can come and they can ask questions about different programs. What are the eligibility criteria, what are the fees, all this information about each of these programs. And then I think they also had like some 20 or 40 different programs, right? So it's like bachelor's or master's program in different engineering courses. There as well, it is, I think, very similar problem, but it also had consistency problem as well, which is around asking question about, what is eligibility. It was not able to understand, or it kind of could not relate to which the question is asked in under what context. So it gave wrong answers, it gave inaccurate answers. Sometimes it was not even consistent. Sometimes it was giving answers for the correct programs, other times it was giving wrong answer. So these two things, and then even there, to solve this, we have to like segment the knowledge base. the knowledge base into smaller pieces. So these two stories I wanted to share. These two are real customer stories that we worked with, and we thought about all the ways to solve this problem. There are other stories as well, but these are two stories I wanted to highlight. And this has the problem of accuracy, consistency. Apart from this, there are other problems that we face early on when building the feature, which is around deployment and iteration and cost considerations, right? So with these stories, I wanted to highlight how going to production with Genie application can be super challenging, and there are a lot of learnings for us that we're going to share in this thing in this webinar. So Joshua, do you want to talk about some challenges that you face with with your customers, or maybe you want to elaborate on what happened with these much more popular stories?
Yeah. I think there were cases that we realized, when we were trying to delegate more of the responsibility to the large language model, that it was, making some sense, but then with that, it would also, it's great at this, putting together the next token. And, how much ever, we can put a probability as zero, your temperature zero, or, top P, etc. We saw funny behaviors every once in a while, and even having this as a black box can cause issues, like you don't know what is going to happen in someone else's deployment. So
Right.
when the models are deployed that way, one day everything's working fine, but if you've given too much of responsibility to that conversational model, right, to deal with knowledge aspects, that's when things get tricky and go wrong. Maybe a weight is gone berserk, right? So yeah, that those are some of the issues that we had when we were thinking perhaps just a neural approach would do it, and
Mhm.
that's when we started combining the strengths of neural as well as symbolic, and brought this together. Yeah.
Got it. So apart from just the accuracy challenges and consistency issues, which Joshua you also mentioned, there are other challenges as well when it comes to going to live, going production. One of them is just building this whole setup, deploying it, making it live, making it ready to handle scale. And it is specifically and its whole AI stack is quite new, so we are still figuring as from engineering point of view, we are still figuring out a lot of things. So there's one thing about going live the first time you're building it, that is one. And second is just iterating on top of it, right? So basically whichever the first version of the application that you want to go live with, whatever the case it may be, as soon as you go live and people start talking to it, you will start realizing there's so many things that is wrong with it, and you have to improve so many things. So you have to have a very clear strategy for iterating on top of the current system. You cannot have something you just make it and hope for the best. So these two aspects of going live, like building the very first thing, very first deployment, and it could be very minimal. You can start very small. It could be just question answering system with, for against a particular knowledge base, and then iterate on top of it. So these two things are also challenges. And lastly, there's a cost consideration, which maybe you can talk more about. Basically it's about just understanding, just knowing that how much you are spending, so that you don't hit a surprise. Okay, this at the end of the day or at the end of the month you have like $1,000 or $10,000 bill. So you have to be careful about how much tokens you are using, how much resources you have allocated for your infrastructure. So there are a lot of other considerations that maybe you can talk about more, right? So yeah, that is pretty much what is the state of, what we talked about the customer concerns. I think next, we are going to show you a demo between, and which basically this demo is going to have a show you a comparison between the vector-based RAG and graph RAG. So this is the topic for our webinar today, which is to compare the accuracy and how do we overcome these challenges about accuracy, consistency, going from normal baseline vector RAG to using a graph RAG kind of system. So I think Jaya will be helping us with showing the demo. So Jaya, do you want to take up?
Hi. Yes. So just to put these concerns into perspective, right, we have built two chatbots that are trained on the same knowledge base, which is a manual for a property management software, right? And this was actually built for one of the biggest international hotel chains. And what they were looking at is they were looking at paving way for digital transformation within their own organization. And they were looking for replacing their property management system. And that is when they came across Agilysys. So we have curated some questions to ask both these chatbots simultaneously, and to give you put it into perspective, right, the average user of this software would be somebody who works on the front desk and manages a lot of the facets of hospitality, like reservation, cancellation, and multiple facets like this. So we're going to ask some questions to both of these chatbots and compare if there's actually any difference to this conversation, right?
Got it. So just to understand, so the customer is the software provider for hospitality industry, right? So someone like a Marriott or a Taj, so they are these like hospitality businesses. They are no, they run hotel chains, and on the front desk, when you go to these hotels, on the front desk, there's a person sitting and they are doing something on their computer on the screen. So they are running this
Right.
software, and we are talking about the manual of this software, basically for that person,
Right.
and and we have made these two chatbots on that basically manual of that software essentially, right?
Alright. So one
Okay.
place we have the vector RAG based AI chatbot, and in the other place we have a graph RAG based AI chatbot. And let's start with a simple question, right? So we want to make multiple reservations under one customer's profile, right? And this is the concern that we are dealing with. So let's start with that simple question and see how it works out.
And both of these chatbots are trained on the same document, right? For the
Same
same
knowledge.
manual. Understood. One of them is baseline WAG, another is graph WAG.
Right. Yeah.
Got it.
So as you can see, both of these were able to decipher the question and generate an output that gives a step-by-step breakdown. But what we can see is that in this case, there is also an alternative, and it's the process is given in a more concise way. Whereas here we can see some redundant process steps that are added in the process that might not be useful for the user per se. Now let's try and actually add some more parameters to this question, right? If we make it a multi-hop question where multiple facets of the manual have to be connected and threaded out to answer a particular question, right? Say we have a query that requires a guest who's bringing in a dog. We need to add the dog's details. We need to add check-in early fees. We need to link the details of the vehicle they're traveling in within the software, right? So if we have to thread these multiple parameters together, let's see if they're both able to connect the dots.
I think the vector RAG already gave up very quickly.
As it's evident, the vector RAG failed to connect these dots. Let's see if right. Yeah. So in this case, it was actually able to connect the dots on multiple requirements that were needed to be added for this reservation, right? So be it a pet's detail, be it the early check-in fees, it was able to create a step-by-step process as to how we can make this reservation into the software. But let's give it a fair shot, and let's try something where we change the context of the question. In a multi-hop question like this, instead of reservation, let's try something else. So we've curated a question which is basically revolves around, say you have an in-house guest who wants to move to a different room, and there's some specifications around housekeeping, and they have some pending financial transactions. So let's see if that makes a difference. So again, as is evident, the vector RAG fails to connect these dots, whereas the graph RAG was pretty much able to very well connect these dots and thread all the multiple parameters that need to be connected together to generate an output. Now, actually, I want Joshua and we need to pitch in here and give us a little bit more context into why this particularly happens, right? Why graph RAG is not able to act at a paramount efficiency in comparison to the graph RAG.
Sure. So I think this is these questions are quite complicated, I think maybe Joshua can talk about how internally it might be happening on the GraphRag side. I think I can talk about
Yeah.
why
So
baseline vector rag is just failing. I think just there are so many concepts in these questions, be it pet or check-in fees, all those things. So it is not able to do, or not able to, with the baseline vector rag, it is not able to find the right snippets of information, and it is not able to connect all them together. And because we have put some guardrails to not hallucinate, to avoid from hallucinating, that's why I just saying ki I cannot answer. Joshua, maybe you can talk about what is happening on the right side.
yeah, so I'm presuming that Jaya has also gone through these answers and she's satisfied with it.
Right.
So the one of the things that you have in a graph rag system, and over and above, I'll probably talk about other stuff later. But in
Right.
a traditional graph rag system, you would be looking at entities and relations, and you would have already structured concepts inside your knowledge system. And so,
Yep.
one of the first steps that we're seeing a lot of the industry picking up to is this idea of breaking down these concepts into entities and relationships, right? And
Right.
so, I'm presuming that this was a quick and dirty setup without any ontology, without any, very rich structure. However, uh, the language model's understanding can be used here to break this down, even the question, for example, into relevant entities and relationships which are chained together. And
Right.
then you can go about finding your right data points and then traverse back up to what you might be seeing on the screen here is from the manual itself,
Yeah.
the exact concepts that are required to answer this question.
Right.
Got
That,
it.
yeah. So
So that's
let's
great. I think
try.
it is able to
Yeah, sure.
just to finish that out. I think it is able to connect these two ideas about pets, about check-in fees, about rescheduling, all those things, right? So it is able to. I think probably will show. No, we'll see in this webinar ki how it actually extracts this information and links them together. So I think that's how it is able to do this. Got it.
Right. Yeah. So, also just to add a little more perspective to this, right? Another important part of working around this software is managing cancellation, right? So let's try a simple question around cancellation as well and see. And we, in this question, basically what we want to do is we want to identify all the reservations that were cancelled because the guest wasn't able to show up at the hotel. So right, like a pretty simple question, both of them were able to answer. But in case of vector, we see that there are some redundant steps which can be done away with in terms of the process. Whereas in case of the graph rag, it was able to give us the concise answer as to how we can navigate through this process without adding a lot of redundant steps. But another thing that we should try is that let's ask a final question, right? So when it comes to users, I think we all have been in a situation where we have dealt with indecisive and probably confused users or clients. So let's try and see if we want to reactivate a profile of a cancelled reservation and because it was a no-show, let's see how we can go about that and if we can find the right process to that, because it again involves connecting two different processes, which is reactivation of a profile and working around the profile that was cancelled. Right. So again, as is evident, it was able to connect those two processes and give us a process and how we can reactivate a profile that was already added into the cancelled list, whereas vector again failed to do so. So the ultimate lingering question here is the biggest lingering question here is that why is it that what are the limitations of vector that hinder it from basically connecting these threads and working through multiple parameters? So I'll give it up to Vineet and Joshua to explain a bit more about that.
Yeah, I think this is the last question that you asked about reactivation. It is quite complicated question because you don't know. I mean, I don't know if there's a specific help doc which explicitly talks about this. Also, if it does talk about it, there's a lot of common ideas which is about activation and booking. So for
Right.
the vector rag or baseline vector rag, it's so honestly it's so hard, and we'll talk about it. Why is that the case? Because in vector rag, the ideas or the concepts are saved in a very broad manner, and that's how it is also retrieved from. So
Right.
figuring for it to figure out the nuances can be very challenging. I think that's what the graph rag thing is actually trying to solve.
Right.
Joshua, any thoughts?
Yeah, I was also wondering if maybe the wording could be different from what is there in the manual. And so it's difficult to understand what reactivate means in this context. Whereas we need to look at the whole query and understand with the rest of the query what is the context of this word, and then look at that concept, look it up maybe in a different form.
Right. But the idea is that no matter how complex the question is, if GraphRag is able to answer it, like what are the limitations that hinder VectorRag from answering it at the same efficiency?
Right.
Right.
Right. So
Right.
again, it's not necessary that like there is this dense space that you have as part of the embedding. However, it's still not necessary that in this context you will be hitting the right points all the time. You've seen the hallucination case where I think maybe that wasn't here, but there are cases where there are hallucinations,
Right.
and that is where it goes wildly wrong, where something's so close to it but it's just triggered off another concept altogether. In this
Right.
case, it's kind of the opposite, where it's not near enough to find it, and therefore it fails, right? So that's what's probably missing here.
Makes sense.
Cool. Thank you, Jeff, for the demo. Thank you, Joshua, and thank you, Vinith. So, Vinith, you want to explain more about, because you have done a lot of deployments with respect to Vector Rack, and you have worked with a lot of projects here, right? So, over to you, Vinith. You can start talking about how Vector Rack works and what are its limitations.
Sure, sure. Cool. So just to give context about before we can compare rag or baseline vector rag with graph rag, first of all, we have to understand what is rag all about. So before talking about how it works, I can just give you why to use it at all, like why even spend time into this. So vector rag or vector search basically improves upon the traditional approach of keyword search. So I think in the next slide, Fabian, if you go, when you know keyword search is basically like how Google works. How basically you uh, ask for a question and it exactly tries to match the exact word or exact phrase or the parts of words with the index database, right? And it has a lot of problem, because if you want to ask something like I want to save money for the future, it will only look for specific keywords like money or future in the knowledge base and try to match it. So that's a keyword search, and it won't be able to do something called something like it won't be able to match with retirement accounts or long-term savings plan, right? So this is like a finance kind of example. So this is where vector search or vector embeddings shine. So vector search can do this very meaningful level or semantic level matching from between the user's queries or user's questions or ideas with the indexed knowledge or text that we have, right? So that is a huge and the best part is that it is very simple to get started. You just if you have a bunch of documents or you have content from your website, some text content, doesn't matter, the text content is it can come from anywhere. You can simply just we have basically built a system. You can simply put it and save it into vector database without any extra work. This is an automated process, and just by doing that only, it has huge benefit of doing something called semantic search or a meaning level search, which was very difficult or not even possible before this thing, right? So it is a huge upgrade over normal keyword based search, but it has its own challenges. It is not the solution to everything. It doesn't have it doesn't have this capability to think about things the way we think about things as humans, right? So coming to how vector rag works, there are two parts to it. There's one part about which is basically true for any kind of search based system, but where you have to first step is to index or ingest the data that you're coming from. And data is basically just think of it like all the content from your blog post, from your website, or a bunch of documents that you have internal documents, all those things, right? So think of the data as a bunch of documents which with text information essentially in it, right? And so the first step is ingesting that data. So this in this image, as you can see, in the left side is a box called data ingestion. So this is where we take these documents, and usually someone who's creating the chatbot, or someone who's creating this conversational experience, they will upload these documents. And it is a two-step process. First is what it does, it basically takes a huge amount of text and it splits into smaller piece. Think of it like 200 or 300 words, and then it takes, and we basically, these are called chunks, text chunks, and we split it primarily around like sentence boundary. There's so many ways to split it as well. So there's so many things I'm actually just skipping over. I'm just trying to keep it simple. But there's so many ways you can split it. You can split it in a paragraph, you can split it on sentence, but basically you split it in a more reasonable or more smaller amount of text content, which can then be embedded. Now the next step is embedding. And to basically for this talk, we'll not go into deep into what is vector embedding, how it works. We'll just, for simplicity, we'll just say that it converts your text string, basically text snippet, into numbers. And basically these are numbers called vectors, and it has basically it is a group of numbers, it's a bunch of numbers, and it saves it into a vector db, where you can do query. So vector db, an example of vector db is VV8 or Pinecone or Quadrant. So these are all examples of vector db. Even a lot of older dbs like Postgres, they also started giving vector embeddings as a format that you can save data in. So these are the two-step process. You basically take a given any document or given a large amount of text, you split into smaller pieces. And the reason that we do it, so that we can make sense of each individual concept more clearly. If you try to embed the whole document, for example, if you have a 20-page document about infosec security, if you try to embed the whole document, it will be, I mean, that won't even make sense, because there are so many concepts, so many ideas in that 20-page document, that it won't even make sense to do any kind of matching on top of it, because it will always match, right? So that's why we split it into maybe like 2 sentences or 3 sentences, where the ideas are much more less. Basically, maybe the one part of the document talks about firewalls or IP whitelisting, and it has only that idea. So that's why we split it, and then we convert into vector embeddings. Basically, it converts into a bunch of numbers and puts into a format where you can do similarity search, right? And I think the best part is to understand is to just think of it like it is putting into a format where you can do a meaning based search or a semantic search, where you understand things at a human level, right? So that's the ingestion part. I hope it's super clear. If you have any questions, feel free to ask. The other part is about retrieval. So that's where the R in RAG comes in. So RAG means retrieval augmented generation. So very first thing is you retrieve information from this vector database, or from pretty much any place. So in this case, we are talking about vector database. So given any user query, so this on the right side, you can see the data retrieval and generation for vector RAG. So in the right side, the user is asking a question. So in this case, the question is, how can I change how can I reactivate the booking that was earlier cancelled because person did not show up, right? Now I want to reactivate it. So that's a user query. What it does, it converts this user query into the same numbers there where all the other document has been split and converted to. So it converts that into the same place. Basically, we call it vector space technically, but basically it's converted into the same format, and it runs an algorithm called similarity algorithm, which checks for similar chunks similar to what the user has asked, the question that user has asked, right? So it tries to find something, some parts of the document or some part of the help docs knowledge base where it talks about reactivation, it talks about booking being cancelled earlier, those kind of stuff. So it tries to basically do that, and that's what it did in the demo, right? Although it failed, but that's what it does, right? So the first step is retrieval, and you retrieve it from the vector search. Once you got the retrieval, you basically have pretty much all the information that you need to generate the final answer, and you give all this information to basically LLM. You have the original question that the user has asked. You also have a prompt. You have a prompt, that's where you basically tell the LLM that you are an assistant. You can help, you are a helpful assistant to help the person with any questions. You give it a bit more contextual information about what company that you work with and what kind of users will. So it has all the awareness about where it is operating. So LLM is almost like you can basically instructing it to be aware about this environment. Along with that prompt, it is giving the user's question and also this context, that the retrieve context that we got, basically, which is almost like the number of chunks that we got. So if we set the value, and we can change this value, we cannot keep this value very high, because then that will overflow the LLM, because LLM also has some capability how much text we can send to LLM. So let's say we pick the top 5 chunks, and each of them are, let's say, 200 words. So we have set 1,000 words as part of the context. We have a prompt which has its own set of words. We have the user's question, and finally we ask the LLM to generate an answer. And what we say in the prompt is that you are an assistant to help the user. This is the context provided. This is the user's question. Now give me the answer. Answer is somewhere in this context, somewhere in this thing, right? And we also put some guardrails in the prompt where we say if we do not find an answer in this context, then just simply say I don't know. Please rephrase the question. And that is exactly what happened with the demo, where it did got some chunks, something similar, but it did not find it relevant to the question. So it just said, I'm not sure, right? In the other case, in the graph rag, we'll talk about how it was able to find it. So that's how pretty much. And then once you give the LLM takes all this information and just generate the final answer. So that is pretty much how the RAG thing works. Very simple explanation of how this thing is actually working. So I hope it's clear. If you have any questions around this, how the RAG works, feel free to ask. Now we'll talk about some of the limitations of it, where it fails. Obviously, we know where it shines. It shines because, compared to keyword search, it cannot do a keyword-based search. So it has to do. It is doing semantic search, which is great, and which is actually allows us to do a lot more things. But when we keep going and try to improve the experience further, we see there are some limitations. First limitation is just the loss of context when chunking. So when you have a large amount of text and you are splitting it, you do not understand. Some of the context gets split. For example, if you are asking, for example, the question that we asked about reactivation, and there are some other information about under which condition the reactivation will happen. If that was split in a separate chunk, that chunk might not be part of the retrieved or the fetched retrieval search. So we kind of miss that information, which is very important to answer the question. So that was the first thing. If you go to the next slide, Fabian. So this is a visual representation of this, where we have a first chunk and second chunk. So basically, it can lead to miscommunication, or it lead to loss of information, and it doesn't have all the information necessary to talk about one thing. Also, some of the information context can be from somewhere outside as well, right? So it has problems like. So I'll talk about the second problem. Fabian, if you go to the previous slide. Before that. Yeah. So the problem is like the similar but contradictory chunks. So as I mentioned, the vector search is doing a very broad level conceptual semantic search, right? So if you're talking about reactivation, or if you're talking about reservation, it will try to match this concept to all the possibilities, all the different chunks out there, and a lot of them will look very similar, and it will be retrieved as a result, but might have contradictory information, or it might not even have relevant information as well. So that is very classic example of this is in the next second slide from here, Fabian. So where in the financial example, it talks about there is an interest rate for savings account, and there's another interest rate for some other product like credit card or something like that. And if you ask the chatbot, okay, tell me the interest rate for this thing, the retrieved result will give the chunks for both of these products, and it will be very likely that the LLM will get confused between these two and just pick one of these. It will not pick both of them, and that will be super unreliable, inconsistent, and inaccurate as well. So that is a misleading retrieval. It's a very huge problem, especially if it's giving wrong answers. So if you're asking for what is the interest rate for savings, and it's giving some random number or an inaccurate number, so that is a huge problem. So that is another limitation of baseline vector RAG. If you go back, Evan. The other things like lack of reasoning capabilities, because as I mentioned, all these chunks are pretty much saved and index and put it into a vector space without any capability to think about this concept separately. Something we'll see that how GraphRag is able to do that at some level. So it doesn't have any reasoning capability around these ingested data. It doesn't have any sometimes also it misses on the retrieval. So if you have a large amount of text which is ingested, let's say 60 100 pages, maybe 1000 pages, it might not be able to fetch all the relevant information across all the documents, because there's a limitation on which number of chunks that you can pass on to LLM. So it can actually miss and it cannot do proper recall at the retrieval step. And finally, there's an underlying assumption about baseline vector RAG is that the answer to all the question that the user is asking, it is single and is localized answer. That means it is not spread across the whole thing, right? So if you're asking questions like summarize this document, this 50-page document for me, basically it has to go through all the chunks and it has to do something extra on top of it, and it's not able to there's no one place unless it has a section called conclusion or something, or somebody maybe it can pick it from there. But if the document doesn't have something like that, it will be very difficult for it to answer those kind of questions. So it is the underlying assumption with the baseline vector RAG at least is that the answers are answer to any questions is localized in some places, so that it can pick it from there, pass it to LLM and generate the answer, right? So these are the limitations currently. These are the challenges that we face. If we move forward in the slide, actually I can. So wait. So yeah, these are the limitations in the current thing. So there are more limitations. Honestly, we can talk about. The vector RAG is very sensitive to noises and outliers. So if it is if there is a wrong information about a certain concept, it will be able to pick it up, and it will be able to. I mean, it's likely that it's going to pick it up, and so it can give an inaccurate answer. Other challenges is like cost of embedding stuff and turning into vectors, because you have to use a model. For example, OpenAI has an embedding model, which I think a lot of people use. And every time you have to embed a text chunk, you have to call this API, and there's a cost attached to it. Although there's a small cost, but there's still a cost. And when you ingested data, when you're also running it, and at the retrieval step as well, you are pretty much you have to basically keep all these vector embeddings into memory, which is also very costly. So this is also another challenge that we have faced in the team as well when we're building our own infrastructure, is that as soon as the number of vector embeddings increase, the memory uses of the instance goes very high, and we have to like scale up until we solve that problem through some other way. Yeah, I think, and finally, I'll just talk one more thing is about the different format, how it handles different formats. So if you have a tabular data, or if you have data or information in some other format in your document, vector RAG will not be able to do justice to that. It will not be able to understand there's a relation, there's some structure to the table, or if you have like a directory kind of thing where you have showed people's name, email in a particular format through some visual way, it won't be able to understand. It will just slurp everything into just normal text. It can seem like it is giving some answers properly if you ask some questions, but it won't be reliable. It's super difficult to make it reliable through this means, unless we somehow give it information about how the underlying structure looks like, right? So that is a big thing as well. When you are ingesting any document which has a lot of different format of data in tabular form, in H1, H2 heading form, it won't be able to do justice to understand all of those things. Finally, I'll just say as part of RAG, which is retrieval augmented generation, the first step is input, which is retrieval, and generation is output. So the most important part of the RAG pipeline is the retrieval, I feel, because when it comes to generation, these large language models are super capable. Even if you use an older model like GPT 3.5, even that model can do a really good job in generating the answer if the retrieve context is correct. But if the retrieve context is incorrect or irrelevant or wrong or missing, then there's nothing that LLM can do. It can only just hallucinate. That's it. That's the only option left for it. But if the retrieve context is good, then it will do a really good job in mitigating hallucination. It can check, it can make sure things are the answer, final answer is good, right? So that's the idea with garbage in, garbage out. So if you have really good retrieved content in retrieved context to the LLM, it will do a really good job. If it's not, it won't. So that's where the problem of vector RAG and graph RAG comes in. The idea with graph RAG is that we come up with new techniques so that at the retrieval step we have much more refined and much more correct information in the right format, which is much more relevant to the user's questions. So that is where the graph RAG will come in. So yeah, that thing will, with this now I'll give it to Joshua to talk more about graph RAG.
Thank you, Vineet. For talking in more detail as to where the vector, is limiting us. And over to you, Joshua. You can explain. We are all curious to know that. Hey, basically, how does this work, and how is it improving the accuracy, right? And we are curious to know because in demo we have clearly seen that GraphRag is overperforming vector, and that's a clear winner there. So over to you, Joshua. You can talk about it.
Thanks. Thanks, Vineet, for that very good coverage on RAG and especially Vector. I'd like to highlight that, Vector has its strengths, as Vineet also covered. It's just that Vector alone will not be, giving you with all those limitations that we just covered, right? So next slide. Another thing is graph alone. Just put in a graph DB. That's not going to solve it either. And there are tons of good frameworks for pipelining, for getting out data in the right format, for putting things together, for orchestrating things. Even a lot of good databases out there, right? So they are not bad, right? We're just not seeing a complete solution that needs to be standardized in the industry, that is reliable, and that can ensure that we don't face another AI winter. So that's the context here, right? Next slide. So this is a high level overview of pretty much what is already being covered. As you can see, like when he spoke about, you need to extract things, you need to he very rightly mentioned the garbage in and garbage out, right? Data is a very important part of this. The better you handle data, the better you get at grounding large language models. And in this whole pipeline, you need to be very careful how you are going to be persisting your data, right? So you need to be interconnecting things that should be interconnected. You need to be able to match them in a fuzzy way as well. You need to also be able to handle different formats, like when you rightly mentioned, if you don't pre-process your tabular data, you're going to get into trouble, right? So you need to ensure that the system knows this data point is related to, say, a column or a row, etc. Right? So on the top, what you're seeing is pretty much your typical pipeline, but with a focus on ensuring that we are using the language model for its strength, which is understanding the data that is being put in, right? And that means that you need to modularize and handle things differently for each special case, depending on if it's a conversation, if it's a document, if it's a video, if it's a table. And that's what CogniSwitch enables people to do as well. You might have even your own extraction, which is very custom to your data, and that's fine. You can connect that via an integration layer to our system, our platform. And on the other side of this, we don't let it be just like that. We think that humans being in the loop and curating this is very important. So don't just leave it to a language model to just understand in terms of maybe common language concepts. Try and gear it to understand in terms of the business domain concepts, right? And this is not something that you just want a machine to do on its own. You would, just like you would do this with any employee that you onboard, you would shadow them, you would be ensuring, ratifying that they're doing the right thing. And this is again where we talk about a curation workflow, orchestrating humans to be in charge of their knowledge, and ensuring that what we are considering as the golden truth is checked off and signed off by businesses, right? So setting that up, sorry, I don't know how long I was. Febin, were you able to hear me?
Yeah, you have a few seconds. It's okay. You can continue, Joshua. It's okay.
Cool. Yeah. Yeah. So setting that up and ensuring that the the ontology of that domain is captured by a system is very important. The idea that we primarily have is to build a digital twin of the domain knowledge of a company, or it could also be an individual, right? So that has to be well defined when you're dealing with the probabilistic model as well, and that makes your data better. It becomes less garbage. You've refined it. You've added multi-dimensional aspects to this. You're ensuring that things like don't just stay as an attribute, as a property, that becomes a first-class citizen inside of your knowledge system, and that can get reused when it's really crucial, when that data point is really crucial. I'm sorry, I think I'm having some technical difficulties here. Um, um, I think I'm back online. Yeah, and the other part of this is um, the other aspect is the retrieval part of this, which is, we need to ensure that we use models that can understand according to that domain, and break down those concepts according to the rules and the logic that we previously mentioned. This will allow them, the machine, to be able to use this in a constrained manner, not in a way that will activate embeddings and cause hallucinations. So this is what we're talking about. Next slide. So this is a simplistic view into what it could look like. This is without any very tight constraining. You can see that common language understanding can allow you to see that there's a reservation that is done for a guest by a user of the system, that is the front desk user. A guest can upgrade his or her room. They can also add in their pets. This can get even more richer and richer according to your domain, and how little pieces can get interrelated with each other. This is a simplistic view into that, into the data layer that we provide. Next slide. So I guess this is in conclusion. Um, it's not about one or the other. You do see that there is your traditional RAG, and a lot of people started off with vectors. Now people are going on to graph, and that's great. But it doesn't stop there. We're talking about using the strengths of both, and ensuring that there is enough provision for the pipeline to be customized according to the business, provision for interrelations of rich concepts, ensuring that you can start to have a system that will be able to infer or deduct things based on events that happen in your universe, right? So this can have a symbiotic relationship. So you start to realize based on your data that hey, now I have a new meta concept that I never knew, gaps that were present in my knowledge, that I need to address. My employees don't know a certain concept, or my customers have been asking about this. And so we're talking about a living breathing thing, which is your knowledge, which even when you think about it in your mind, you need to keep updating, and you need to keep reasoning why this thing is correct for you, right? That reason could change tomorrow. So that is where we're talking about a fusion approach, where we're talking about combining the best of all these worlds, where we're talking about if there was, why is there poop in this hotel room, right? And you already had systems connected, and you had this thing that someone asked for a pet inside this room. They asked for an upgrade, and you can actually traverse back, and somebody who's at the ground level, they can actually find out in a real life scenario via a deduction going backwards why this happened, right? And this can be even more and more dynamically handled, depending on the data that's made available, depending on how you manage that data. And that's what we're talking about, both the life situation and your knowledge concepts in terms of your procedural SOPs and product manuals and whatever else that makes a digital twin of that company's domain. Yeah, I'll
Vishal,
stop here.
just
Yeah,
interrupt here.
yeah,
Yeah. So just to understand, no, I think there's a bit of, I think we talked about a bit more about the technology side of things, but just trying to keep it very simple, no, to just to get an intuitive understanding. I think what you mentioned, and maybe you can go to previous slide. Maybe I can just go there. I think what is happening here is um, when you are trying to doing the ingestion step of, making something like a graph rag, you have you have a text
inside out.
data.
So,
You have a
so
text
the other,
data,
yeah, yeah,
and you are basically converting and basically trying to build more structure in that text data. So basically you are trying to extract concepts. For example, if you take this example of basically a software, for hospitality business, there will be concepts like guest, there will be concepts like reservations, there will be concepts like room, or a hotel or property, all those things, right? So
right,
what I think what you are saying is to and all of these concepts are just written. These are like words in when you're reading the help docs, for this particular software. So what you
and
are
then
saying
mentioning,
is that with this
yeah,
graph rag technique, during the ingestion step, we basically go through maybe each of these, maybe sentence wise or paragraph level, like on a per sentence level, try to extract these concept, and then build these. And from that, each concept is basically an entity which is a node in the graph, and how two nodes or two concepts are related to each other, and that is
yeah,
basically a relationship.
yeah,
For example, a
yeah.
guest. Yeah.
So Vineet,
So yeah.
thanks for that. So basically, using the anchor of the previous one of the previous slides, right, where you mentioned that chunks of text, right, where you're just looking at like the first level, right, which is you're
Mm.
looking at a body of text. Now you're taking
Right.
that and you're turning it inside out, right, where you
Right.
have uh, inside that body you have these entities and relations, right, which you just mentioned, and that connects from that level downwards into the right pieces of text, the larger piece of text. Because one of the limitations that we're talking about is it's going to have a lot of noise if you have like all
Mm.
of those concepts just jammed together, right? So you want to get
Right.
to the point, you want to get exactly that entity or exactly that relation, and then go up the stack, right? So that's
Got
in
it.
comparison to the chunks, this would be a way to get that better, right?
So all the chunks means all the text, original text that came from the help docs, that is still there, but it is now connected to that concept, so that once somebody reaches to this concept, they can refer as a reference. They can refer to all the text chunk as it is, and possibly even pass on
Exactly.
to LLMs. That
Exactly.
is
So
okay. Got
even
it.
when you have like human in the loop, like I mentioned for the curation, right? Supposing someone finds that, no, I want to word this differently, right? I don't want to call this reservation. I have a special term for this, right? They can go back
Mm.
even to, okay, why did reservation come? We got it from your text, right? We got it. If
Right.
you go backwards, if you do an audit, right, we have that in our pipeline.
Mm.
You got it from that text. That's why the language model is
Right.
said reservation, right? And then if you went and updated that, right, now you're introducing a UX where you would be updating, inside out, right? You'd be looking at concepts like
Right.
this, and then you'd be updating your documents on the fly, right? So like
Right.
that's the aspect of knowledge that is going to be dynamic.
Yes.
Uh, it's
Definitely, I
something that,
think that will be super useful. That could
yeah,
be very super useful because people might want to update the names, or they want to refer to something else. My question
maybe
is again, I
refund
would say,
percentage. Yeah.
yeah, yeah.
Yeah,
So I'm
refund
still want to
percentage could
kind
be
of
10% to 20%, and that needs to be
right.
updated in the document, right? So that's another example of how
True,
that
true,
could
true.
be. Yeah.
True, true. So I'll just want to go a bit more deep. I think we're also very close to completing the webinar as well. But the other part about the retrieval, which is once you have this graph, I think you're showing this right now. You're talking about this one node called guest. It is connected to reservation. Another node, it's connected to user, which is the user of the software, basically person sitting on the front desk. There's another concept called pet. So all of these concepts are there. They are related to each other with some relationship. Now, and this is done. This is like ingestion. It is already completed. Now, when you go to the retrieval step, how does that work? Like, how does the retrieval pipeline work? How does, is it like querying in this graph and then figuring out the chunks? Like, how does that work?
Yeah. So in the case where you're using not just a vector, you're using this graph approach, you would be looking at breaking down the query, understanding the query into what is it. Maybe, like you mentioned, the multi-hop, right? You had that the pet, and then you had, like, I think, upgrade of a room, right? So it's not necessary that all of them are together, right? It will be maybe a hierarchical, there is a clause here which has a sub clause, right? I have a pet, but then that pet needs his own room, right? He needs a special kind of room, right? So depending on that, or maybe it's two separate, not hierarchical, but two separate queries altogether, right? So those two, understanding that query, breaking it down is very essential. That is one. Then the next part of this is, if it is hierarchical, for example, you need to be able to have the resolution to the first query, the innermost query, and then go outwards, right? So if it is, can I get a special upgrade for a pet? Yes, no, right? And then you go outward into what pets are allowed, or whatever, however the question was phrased, right? Then you start to go outward and outward, right? This might be more useful in a legal scenario where you have, like, section 3.2.3, whatever, and you start to get drilled down into voluminous data. You start to drill down into, like, hey, where's that needle in that haystack? And you start to, like, see the utility of this and how it can interrelate and create patterns that are, maybe, you're referring to different concepts, but the patterns are the same. So
Understood.
that's where.
So basically, given any query, given any questions, user's question, which is just natural language text, it tries to first convert that into a query which can be executed on this graph system.
Correct. Into our data layer, which can then consider, okay, do we need to be reasoning, or is this like a straight up just retrieve this concept? Is there any other way of representing this, right? Is there any reason why we need to expand this query? When I say expand, it could be that there are some assumptions in that question. You need to get some other concepts, right? This is where possibly even some neural approach will also benefit. So that's why I said, at times the system has to also use some amount of embedding, right? But we're trying to keep it as deterministic as possible, where we are very sure why we got that concept. If you're not sure about that, then you can't rely on that. So that data, the data out that you're talking about, that has to be reliable. Once that is reliable, then you're talking about a conversational interface where we maybe adjust for tone, do some guard railing on don't say something that is not clear here, etc., etc. That's a conversational. But the data part has to be very clear. Yeah.
Understood. So finally, just to connect the dot, if in this diagram, in this thing, on the right side you have the pretty much the retrieve the RAG pipeline, and on the left side, this is going to get replaced with the graph RAG kind of system. And this vector search, which is connecting these two blocks, instead of vector search, it will be a graph search kind of.
Right. And we're talking about further, like, not just
search.
graph RAG.
Once the retrieve content.
We're talking about a level above that, where we see that there will be limitations even in graph. We're talking about, we need to have a logical, like, hey, if A implies B and B implies C, the existence of statement A has to imply C, right? We're talking about that level of crisp logic, of reasoning, which was anyway present in a symbolic system. It's just that people have forgotten it, right? So we're talking about bringing these two neural and symbolic approaches together. So we're talking about a true fusion where, yeah, it is retrieval. You're augmenting the generation based on the retrieval. That's fine. But the
Right.
basis is more than graph. Graph is also good. Vector is also good. But we're talking about upping the game and going
Right.
to what we call fusion RAG. Yeah.
Understood. So basically, definitely. So there are more things involved. As retrieval is definitely, there's so many more things is there. But once the retrieval is done, then the rest of it's pretty much same. I think there's a prompt, there's a
Yeah.
context,
High
there's a
level
question, and yeah,
abstractions, yeah, will remain
got it.
similar. Yeah.
Understood. So I think overall, what I can see, what I understand, and the big takeaway from this is that the retrieval step is super important. How you ingest the data, how you are retrieving it at the query time, at the time of the user is asking. It could be vector RAG baseline, it could be graph, it could be fusion, and there's so many things you can do. As you said, beyond graph, there is about also things about symbolic understanding, about reasoning, logical reasoning, where you need more clear and crisp understanding of the concepts as well, right? And there's, I think there's so much things that has to be done. I think that's just right now just a beginning of how graph thing works. Even how are we extracting entities out of the unstructured data? Even that is also, there's so much things you can do there. You can interpret the same thing, same word in so many different ways.
Exactly.
So there's so many things. I think that's the idea of ontology also comes in, where you have a set template on which you are interpreting it, rather than just being it very ambiguous. So I think that is the key takeaway, is that in the RAG pipeline, our part, which is retrieval, is super critical, and it pretty much covers vector or graph or anything like that. And there's so much you can do. And graph has graph RAG technique is basically very much useful, because you can actually create concrete ideas which you can actually see and update manually as well, and use it to generate more accurate and more consistent answers, right? So I think that pretty much solves, I'm not solve, but that's actually approach to solve that problem of accuracy and consistency.
Yeah.
Right.
Anyone who says
Cool.
it's solved is probably not in the same universe, but yeah.
Yeah, of course, it's not solved. It's very still, there's a lot of things to be figured out.
Cool. Thank you, Joshua. Thank you, Vineet, for explaining. And I feel that there is a lot more to cover, and I think we will have more webinars to to go into more details of it. I would suggest that you guys follow Task, Cogniswitch, Vineet, Joshua. And the next step, of course, is that make sure you try both of our platforms. We have a DIY builder and even Cogniswitch. You can get in touch with their team and they will help you out if you want to get started. We also have a Discord channel which you can join. Also, Cogniswitch has LangChain packs as well. So if you most of the developers who are into building Gen AI apps knows LangChain and LlamaIndex, so you can get Cogniswitch there as well. And please feel free to reach out to us. And also, one more thing is that if you want to us to cover something specific, please add that in the comment section, so that the next time we will be able to do that. Yeah.
Thanks a lot, Vineet and Febin.
Thanks a lot, guys. Do we have any questions, Febin?
I think Vivek is taking that question offline, so I think we are good to go. Yeah.
All right.
All right.
Cool. Thank you.
Thank you.
Bye.
Thanks, guys. See you.